Hello, good afternoon, everyone. I think that it's for two. We can start with the presentation. First, let me tell you thank you. Thank you for joining us to the presentation of the new solution in our marine division, the drone Bathy 1800. We are pleased to show you today the features, workflow, and performance of the drone, of this new drone in the market. The drone 1800 is the result of a successful collaboration between IMS Solution, French company who has developed the drone, together with Prime GPS, company of our group, of the group Arcans, which has collaborated in the integration of the hydrographic sensors in the drone. Please, if you have any questions during the presentation, feel free to type them in the chat, and we will answer them at the end of the presentation. In case that we run out of time, we will respond them by email, right? So let me introduce first my colleagues who are hosting this presentation with me. So first we have Julian Lambert, the captain of the boat. He's the application engineer. He's an application engineer and a specialist in machine control system for marine application and hydrographic sensors. That includes, of course, the drone that we are going to present today. And before joining to the group Arcans, he has worked in a surveying company for many years, doing bathymetric projects using 3D scanners. So he has a huge background about marine survey, and he's available to answer your question at the end of the presentation. My colleague Francis Demerci, sales engineer in Alterra Belux, that from the group Arcans as well. He's not as young as Julian, though he has longer background, and he's responsible for the marine solutions in the Benelux region. So you can address to him if you are interested in the solution and if you want to get more information about the solution. He speaks Dutch, French, and English, so he's the perfect contact for asking information. And the last, me. My name is Ruben Buron, surveying engineer, and I've been working in Alterra Belux for almost 5 years in training and support department as a specialized in 3D solutions. And previously I worked in Spain for 8 years in a position similar. And from June of last year, I'm working in the group Arcans as international business developer for 3 different divisions. It's for Scan2Bin, Railway, and of course the Marine division that we are gonna talk today. So let's jump in to the agenda. First of all is a briefly presentation of the company, of the group Arcans and Alterra Belux. Then we are gonna talk about general concepts regarding bathymetry and drones. The next step is gonna be to talk in detail about the hardware and features of our drone, the drone Bathy 1800, the workflow as well, to capture the data, to process the data, and to get the information from the data, and the performance, what is the benefits of our solution, and at the end of the presentation, pricing, and to answer the questions that you can write or type in the chat. So let's start. Organization. What is the organization of Arcans as a group? Arcans group is composed of several subsidiaries to be able to respond to each phase of a project, the design, the construction, utilization, and maintenance phase for building and infrastructure projects, as well as marine infrastructures. One company of the group is Arcan System. Arcan System is dealer of Trimble and Autodesk BIM and CAD software. In addition, Arcan System, we developed applications in order to provide the complete solution to our customers in the building and civil construction market. Then another subsidiary of the group Arcans is Alterra Belux and Cytec. We are dealer of geospatial and heavy construction division of Trimble. This includes the hardware to capture the data, such as 3D scanners, GPS, machine control system for earth-moving machines, and the software to process the data and get the information. Another subsidiary of the company is Arcan's Optimum, that is specialized in solutions for management of queries. That in Arcan's Optimum, we can provide different applications for monitoring and managing the works in the queries. And last but not least, another subsidiary of the group is Prime GPS. All clients or companies who are in the world of marine probably know Prime GPS. Prime GPS is specialized in marine construction and hydrography applications. Is part of the group Arcan from July 2019. There are in Prime GPS there are 5 employees, 5 experts working in the division, and the main fields of the activity of Prime GPS are hydrography survey. We are dealer of multiple companies to provide hardware and software, such as Orbit for multi-beam sonar, monitoring of structures, which again, with the multi-beam orbit and LiDAR, we can collect the data under and above the water. An example of this type of solution or project is that Prime GPS has provided the complete solution for the project in Monaco, all the sensors to measure under the water. Another field of activities, marine machine control. So we are dealer of Teledyne and Trimble for this type of solution. And development. In Prime GPS, we develop and do integration of a specific solution. An example is for military applications. So we can collaborate with our customers to find the better solution for them. Where Arcans is present, as you can see here in the map, to support our customer, we have offices along Europe. We are present in Belgium, in Netherlands, Poland, Romania, or Sweden. So different locations to support our customers. Okay, we start with the bathymetry. That is the first question. What is the bathymetry? Bathymetry is the study of the beds or floors of water bodies, including the ocean, rivers, streams, and lakes. When we say that, when we use the term bathymetry, we usually refer to the submarine topography, or in other words, the depths and shapes of underwater terrain. And in order to get the topography map, first we have to collect the data. There are different types of sensors, single beams, multi-beams, etc. And they are mounted in multiple types of platform vessels, survey vessel or another standard vessel, or in a drone, like we are going to talk about. And then once that we have collected the data, most of the cases we need to post-process the data in order to get the DTM, the digital terrain model. The results, once that we have processed the data, is going to be the map. A 3D map would represent the three-dimensional features of overland terrain, the relief. As you can see in the picture on the left, we can see the variation in seafloor relief depicted by color and contour lines called depth contours or isobats. Application of the bathymetry. Well, most of you knows what is the application for bathymetric the bathymetric project. First is to get the 3D topographic map of the seafloor. The same for rivers, streams, or quarries. If we can combine the sonar with the LiDAR, then we can get the digital model not only under the water, we can get the digital model as well about the water, as you can see here in the screenshot. Second application, construction, monitoring, and maintenance in dredging, earthwork, and infrastructure project. So in the main phases of the project, we can measure collect the data to get the surface, the 3D model, in order to control, to monitor, to be sure that we accomplish all the requirements of the project. And third one, construction and control structures such as dams, dikes, ports, and wind farms. It's quite similar that the second one for all the phases of the projects for dams, dikes, ports, and wind farms, as you can see in the picture, and more. So I'm pretty sure that you not only use your bathymetry system in case that you have, it's for the three applications that I mentioned. There are quite more hydrographic application that you can use the system. So that is concerning the bathymetry general concepts. We start talking about bathymetry solution on the market. That the standard solution is that we mount the sonar and the lidar, the hydrographic system or sensors in a vessel. Could be a survey vessel or a temporary vessel. There are advantages for this type of platforms to put the sensors. First is autonomy, of course, and then you can put multiple sensors. But at the same time, it's true that this type of platform vessels, it has significant cost, and the transit time is an issue as well. To move from one construction site to another one is not that easy. And in case of temporary vessels, the time for the installation and especially the calibration of the system, or the multi-beam system, or the LiDAR system, takes time, 1.5 to 2 days to have the system ready to start capturing the data. So what is the other platform where we can install our sensor, our multi-beam to get the bathymetry? Is drone. So what is the advantage of the drone? This is the question. Why should I use a drone? Probably the first two question marks are the calibration time that we mentioned before, and the other one is the easy transport from one construction site and the another one. But instead of reply to this question now, that's the idea, is to show you the features and the performance on the drone, and then we can see what is the benefits and why should I use a drone? Why should you use a drone for the bathymetric system? Okay, let's talk about the hardware of the drone. For one part, we have the monodrone, the platform that it has been developed by IMS Solutions. This is a French company. And it's important to mention that it's a multi-sensor platform. We can provide the solution, an integrated solution with the multi-beam system, with the Norbit multi-beam system, but at the same time, if you need a platform for another type of projects with another type of sensors, it's possible to use it as well. And then we have the hydrographic sensor. In this case, is the multi-beam system, the Norbit multi-beam system that integrates the inertial system uplannings to get accuracy between 2-5 centimeters. And the features of the system is versatile, autonomy, easy to use, and precision. Okay, more components of the drone. We have here first the PC to create the mission and to configure acquisition of the data, the autopilot to manage to operate the drone remotely. Then we have two cameras with different orientations. One is a front camera and a rear camera. The front camera is for the pilotage, for pilot the drone, and the rear camera is basically to control the winch to see if it's working properly, and the profiler that is on the winch, the profiler IML that we provide with the drone. The maximal distance, well, the winch can go down until 30 meters, but we can upgrade it until 100 meters. It's possible until 100 meters, and the profiler is to measure the celerity of the water column in order to correct the sonar and get better results. More components of our drone. We have here the two GPS GNSS antennas in order to get the heading of the drone with centimetric accuracy. Then we have the option of put the LiDAR to get the, as I mentioned before, to register and collect the point cloud, the 3D data above the water, and the multi-beam system. The multi-beam system IWBMS, the Norbit of Norbit, installing the gravity center of the drone. And to handle the drone, we have two options here: the remote control to handle it manually, or with the Trimble T10, we can install the Norbit DCT or the Norbit DCT to manage the multi-beam system, and the autopilot software to manage the drone automatically. We are going to see it in detail in the workflow. Features of the drone: first, communication. Then the system integrates two antennas, two GSM antennas, in order to get the correction from the GNSS network services and get the centimeter accuracy. We use as well the 3G and 4G connection for driving, to pilot the drone as well. We have the telemetry stations, the Wi-Fi 5 gigahertz. Then the maximal distance that we can arrive with that is 2 kilometers. So it's not that bad. And then it's the radio remote control in order to manage the drone. GNSS corrections, so we can receive the correction from multiple, from different ways, GNSS network services as Trimble VRS Now, or Walcourse or Flepos for Flanders. And then we have the other option is receive the correction via radio from a GNSS base station, or it's as well compatible with Marine Star. And the third group of features is acquisition and post-processing software. That's an important point as well. It's because the system, the solution is compatible with the main software provider for the acquisition and for the post-processing and for processing the data. So it's that you don't have to adapt yourself to the drone. Your workflow, it's the opposite. The drone adapt the way that you work. Talking about workflow, we are going to start to measure, to register, to collect the data. So what is the first step is setting a mission preparation. That's an important thing. As you can see in the picture, we can transport the drone in a van, a regular van here, and then it takes no longer than 15 minutes between we take it out from the van until we put it in the water. 15 minutes, that we say that it's easy to transport. Next step in the workflow is to put the drone in the water. This is a video just to show you. Here is my colleagues. Is with the trolley. You can see that the drone is in the trolley. Pop. From the van to the water, no more than 50 minutes. And then we can start to configuring the multi-beam system and the mission to collect the data. So once that we have the drone in the water, this is a screenshot of the autopilot software. It's to define the fence. What is with a polygon? What is the area that we want to measure? There are different ways to do it, just with waypoints that we can select in Google Maps. So just use the drone itself to measure or to define the fence, the area. Once that we have done the fence, we have different parameters to define the trajectory that the drone is going to follow automatically. That's an important point. To register, to collect the data with the multi-beam and with the LiDAR in the case that your drone has the LiDAR. Here in these screenshots, in the purple color on the right picture, you can see the route that the drone has done, and on the left side you can see the Teledyne software, where we can see in real time the 3D model of the seafloor. In this case, we can see as well the image of the camera is a high resolution camera, 1080p, And then, as you can, I don't know if the resolution is good enough, there are some safety tools to guarantee the security, the safety of your drone. So that's the data capture. We are collecting the data. We also can collect the image. That is something that is in the EWBMS. In the Norbit multibeam is something that is a standard. So you can capture as well the images at the same time that the model. And the Norbit multibeam, the EWBMS, with this type of multibeam system, we can turn it. Then that we can do is to collect the data or collect the points of the objects that are sites on the sites. I don't know if you appreciate here in the images that you are collected the bottom, but at the same time the side of the dig. And as the drone has the LiDAR, we are collecting as well the point cloud of the features of the structure above the water. Data capture. We continue with the data capture. So we can see here, that's a screenshot where shows that we have finished our project, and then the drone automatically goes to the first point, and then we can take the control manually of the drone just to put it again on the trolley. That's a video just to show you that. We have different type of trolleys in order to adapt to the conditions of the construction site. Pop, drone on the trolley, and we can go to the next construction site. That's the results. That is an example that we can collect. It's a combination of LiDAR and multi-beam capturing data, and you can see the different colors in function of the depth in the other image. Third step in the workflow, post-processing the data, the rendering. So we have the raw data, and then normally that we have to do is to clean this point cloud in order to have the final as-built situation of the structure or the digital model of the button. So that is post-processing rendering, as I mentioned, is compatible with all the standard post-processing software in the market. You can see here some screenshots, data capture with the drone. Then here it's that, why should I use a drone? Where should I? Here it's the performance. What is probably some of the reasons that is a high performance solution? Versatility, quick and easy transport and installation, easy to use, reliability, high accuracy and performance, long range and autonomy. Versatility. Why we say that is a versatile system? First, because it's a multi-sensor platform. It's not only for one type of projects. We can use it for multiple projects. We can integrate some cameras. We can integrate as well, instead of the multi-beam, we can single beam, install the single beam. We say as well that it's versatile because we can measure shallow waters, that it's the minimal depth is 70 centimeters. So there are for many projects that's an important thing. And it's versatile as well because we can work with it, with the drone, in turbulence water. So we can navigate, the drone can navigate with waves of 1.5 meters, and to collect the data, it's 60 centimeters high of the waves. We are gonna have good and high precision results. And then we can use it for maritime and river projects because it's turbulence water, deep and shallow water, so versatile system. Reliability, expertise. That's a drone that has been developed for a French company with the collaboration between Prime GPS and IMS solution. There is an expert team behind that, so that's important for development of the drone. After is for the materials, is composite, the materials, and the sensor, which are integrated. We are talking about Norbit, we are talking about, for the inertial system, about Aplanis, so we are talking all the time about high technology sensors. Third one, high accuracy and performance. Well, I already mentioned that we can get between 2 5 centimeter with our multi-beam on the drone, and the performance, it's an average is 2 hectares per hour. That's that is the performance that we can get in a speed of 1.5 meters per second. So that's the performance of the system. More options, sorry, no. More performance of the system, more features, quick and easy transport and installation. The dimension, that's the reason of the name 1800. It's because it's 1.8 meters, 0.70 meters. We can, with 2 operators, we can put it on the water, as we have seen in the video. We have multiple trolley options to put the trolley in the water, and as I mentioned, assembly and production time is just 15 minutes from the van to the water. 15 minutes. Easy to use. It's the software that you have seen in the workflow is the Teledyne that and the autopilot. It's developed for ourselves, and then it's the operator doesn't need hydrographic skills to be able to use to operate the drone. And the last, long range and autonomy. The communication range is until 2 kilometers from the operator, and the battery life it's around 8 hours. So, and with this slide, I finished the part of the performance and feature of the drone, and then my colleague Francis can talk you about the proposal that we can give you. Francis?
Okay, thank you very much, Ruben. So we were pretty excited to add this drone to our portfolio. And the following slide is the offer. Oh, I have to wait for Ruben to click. Ruben, can you? Okay, this is the offer.
Yeah, sorry.
Okay.
Yeah.
No. So this is the pricing offer. 245,000 euros, but this includes the monodrome, so the vessel itself, the multi-beam system, a Trimble T10 tablets, that's for the software, the guidance software, and the to prepare your survey, a launching system, and the CTD probe. So that's all included in that price. We also rent out this equipment. Pricing is at 1,200 euros a day. This does not include the shipping cost and the training. Okay, so this is really for the monodrome, the multi-beam system, the tablet, the launching system, and again the CTD probe. So that's, I had a question about this. So this is the rental price. We also provide training. Okay, it is a 3-day training at, again, 1,200 euros a day. You can see what we give in that training. So the first day is really on the UAV theory, the description of the machine, navigation, and then learning to drive and how maneuverable it is. So this is pretty basic. And then 1 day for the onboard system, the loading of the mission plans, the management of breakdowns, so procedures. That's 1 full day on those topics. And then we have 1 day for the really multi-beam configuration and usage. So for that, that's really the acquisition of the data. We also have 1 day of training. If you have knowledge of one of those 3 items, you can leave it out. I can imagine that some of you have knowledge of Norbit systems. Of course, you do not have to retake that day. The monodrone itself is also available as a platform. Okay, this pricing is not in here, but we do integrate your own. If you have your own Norbit system or other systems, we can also integrate them on this platform. If you have questions about that, please contact us. There are some options with this vessel, the launching trolley, a transport case, a replacement engine and propeller, the LiDAR, I think that is the most important. So you can add a LiDAR to the Norbit system, so you can scan in everything that is on land also. We also give training in data processing. Pricing for that is on demand. We also can provide data processing as such. Also, this pricing is on demand. I hope you understand that this depends on the amount of data, what we need to do. So those pricings are given on demand. Okay, Ruben.
Yeah.
Okay, so Altera Belux is your partner for the Benelux area. So you can contact us to give a demo, to ask for information on a solution that needs customization. So if you want to implement your own systems on this platform, we can help you with that. We also provide training, as mentioned in the offer. And of course, we have people standing by for technical support and training and repairs on this type of equipment. So for that, your partner within the Benelux area is Altera Belux. Some of you know us from the surveying activities we do and machine control activities we do, but for this type of equipment, marine equipment, you can also contact us from now on. Okay. Okay, so of course this is a web presentation. We are planning to do a presentation or show you this new equipment or this new technology in real life. This will be organized between the 25th and the 29th of January 2021. Where? At the port of Bruges. So it will not be in Zeebrugge. My son is a member of the Sea Scouting in Bruges. They have a beautiful location next to the docks in Bruges, and we will be holding the demo over there. Okay. Why a whole week? If you are interested, contact us, and we will try to avoid big groups. So we will invite company per company. You will each get a slot. And this, of course, has to do, that's why I put it in there, the question mark, with COVID-19. And also, now we are planning this, but of course, we are really, really dependent of regulations around COVID-19 in January. We will keep you informed. But at this moment, our plan is to organize a week of demos in that week in Bruges. Okay, if for one or another reason, well, another reason will be COVID-19, we are not able to do so, we will inform you. But keep these dates free in your agenda. If you are interested for a real life demo,